Shri Gurubhyo Namaha. Harihi Om. Sahana Bhavatu Sahano Bhunaktu Saha Viryam Karavavahai Tejasvinavadhitamastu ma vidvishavahai. Om Shanti Shanti Shanti. Harihi Om Tat Sat. Shri Ramakrishna Arpanamastu. Om Sthapakaya च ब्रह्मस्य सर्वधर्मस्वरूपिणे अवतारवरिष्ठाय रामकृष्णाय ते नमः. जननीं शारदां देवीं रामकृष्णं जगद्गुरुं पादपद्मे तयो श्रित्वा प्रणमामि मुहुर्मुहुः. ॐ नमः श्रीयतिराजाय विवेकानन्दसूरये सच्चित् सुख स्वरूपाय स्वामिने तापहारिणे. ओम गुरुर्ब्रह्मा गुरुर्विष्णुः गुरुदेवो महेश्वरः गुरुरेव परं ब्रह्म तस्मै श्री गुरवे नमः. अखण्डमण्डलाकारं व्याप्तं येन चराचरं तत्पदं दर्शितं येन तस्मै श्री गुरवे नमः.
In order to measure any physical quantity in the universe, we use a standard reference called as unit. That may be any physical quantity. That may be distance, that may be weight, whatever may be the physical quantity in the universe. In order to measure it, we are using unit. So how we measure the physical quantity? In order to measure the physical quantity, we are taking a number. Example, in the 5 kg, 5 is the number and kg, here it is representing the unit. So to measure the physical quantity, we are taking a number followed by the unit. This is how we measure any physical quantity in the universe. We have many physical quantities. It is not possible to remember the units of all physical quantities. In order to avoid this problem, we are classifying the units into 2 categories. The first category we are calling them as fundamental or base units. Second category we are calling them as derived units. What is the necessity to divide the units into fundamental and derived units? Fundamental units are the main units by using which we can express the derived units. So if we learn the fundamental units, we already at that time learned the derived units also. So the combination of these fundamental units and derived units, we are calling them as system of units. Now in this chapter, we will learn about the fundamental units. If you learn the fundamental units, with the help of these fundamental units, we will also indicate the derived units. With the help of that, we will try to measure the all physical quantities in your surroundings and in entire universe. Now we are discussing about the international system of the units. Previously, different countries used different systems of the units for the measurement. The main popular units are CGS, FPS, and MKS units. The base units which they have considered are length, mass, and time. These are the fundamental units in all these 3 systems. In CGS system, the unit for the length is centimeter, whereas in FPS system, the unit for the length is foot. 1 foot, 2 foot, 3 foot, like that. This is a British system. And similarly, in MKS system, meter. Meter is very familiar term to us. And in CGS system, the unit for mass is gram. And in FPS system, the unit for mass is pound. Similarly, in MKS system, the unit for mass is kilogram. And in MKS system, the unit for time is second And in FPS system and in CGS systems also the unit for time second. In all the three system of units, the common unit for time is second. Now internationally we are using the SI system, which is the French for international system of the units. They have implemented this SI system initially for their geographical purpose in the France area, and finally they accept the entire physics community of the world. They accepted in 1971 as the international standard of units, and in 2018 they have revised these units. Now we will discuss about SI units. In SI units, we have 7 base units, which we also call as fundamental units. One is length and mass, time, electric current, temperature, amount of substance, and luminous intensity. Apart from these 7 base units, we also have 2 more units. One is plane angle and the second one is solid angle. What is this plane angle? When we take the angle between two lines in the same plane, that angle is called as plane angle. So that is represented with d theta. And similarly, what is the solid angle? If we take the angle between two planes, this is one plane and this is one plane, example, then the angle between these two planes we are representing with d omega. This is the solid angle. Now for the length in the SI system, the unit is meter. We are representing with small m. Similarly, for mass, the unit is kilogram. We are representing with kg. And for time, the unit is second. We are representing with small s. But for electric current, the unit is ampere. We are representing with capital A because ampere is the name of a scientist. Now, similarly, the temperature unit is Kelvin. We are representing with capital K because he is a scientist. Amount of substance unit is mole. We are representing with MOL because M is already designated for meter. In order to differentiate between meter and mole, we are taking MOL. Similarly, luminous intensity, we are taking the candela CD. Because C is designated to some other unit, we are taking CD. There are 2 more units, plane angle and the solid angle. For the plane angle, the unit is radian. We are representing with RAD. And for solid angle, the unit is steradian. We are representing with SR. These are the different types of units which we are using in daily life. Through SI system, how we can measure them. Minute means 60 seconds. Hour means 3600 seconds. Day means 86,400 seconds. Because in SI system, there is no day, only second. In SI system, there is no hour, there is no year. Only the unit for the time is second. We are expressing minute, hour, day, year in the form of the second. And similarly, degree. There is no term as a degree in the SI system. So we have radian. So 1 degree is equal to pi by 180 radians. Similarly, if you want to measure some 90 degrees, then it is nothing but 90 pi by 180 radians. Like that, we have to measure. And we are representing ton 10 to the power 3 kg because there is no term as ton in SI unit. And similarly, carat 200 milligrams. Like that, some more physical quantities. Whenever we are representing for them, generally we take some other units, but in SI unit, the equivalent measurement is given here. Okay, so ampere is the scientist name. Because ampere is a name, we are not writing with the small letter. Do you understand the difference? We have written M as a small letter. See, M we have written small letter. M represents what? M means?
Meter.
Very good. Kg small letters. Kg means?
Kilogram.
Okay. S small letter. S means?
Second.
Very good. But A we are writing capital letter. Why? Why cannot we write A as in small letter? Because ampere is the name of scientist. Why we are giving the name of the scientist? Because he has done some work which is useful for the physics community. So in order to appreciate his effort, we have taken his name as the unit for the electric current. Okay, why we are not writing the ampere in the small letter? What is the reason? It is the name of a
A
scientist.
scientist.
Okay, that's why capital A. And what is the unit for temperature?
Kelvin.
Again, we
Kelvin.
have written capital letter. Why?
Because it's also a name of a scientist.
Very good. Kelvin is also name of the a famous physicist. So Kelvin, it is the name of the scientist. We are taking capital K. Okay. Now amount of the substance, we call it is the mole and we represent with the MOL. Why we are not representing with M?
Because M represents meter.
Meter, absolutely. That's why we are taking MOL. It is simple, easy. It is easy to understand. Even though amount of substance unit is mole, we are not taking the M because M is already given for the some other unit. Okay, right. What is the luminous intensity units? Candela.
Candela.
Okay. So candela we are representing with CD. Small c, small d. How many base units we are taking in the SI system?
7.
Very good.
7.
What is the unit for length in the SI system?
Meter.
Very good. The symbol we are taking?
M.
Very good. And mass? What is the unit for mass in SI system?
Kilogram.
The symbol we are taking?
Kg.
K.
Very good. Next, what is the unit for time?
Second.
Second.
The symbol we are taking?
S.
Very good. Now, what is the unit for electric current?
Ampere.
Ampere. The symbol we are taking?
A.
A.
A. Whether A is small a or capital A?
Capital A.
Why we are taking the capital A?
Because A is the name of a scientist.
Scientist.
Ampere is the name of a
Ampere.
scientist.
Scientist. Okay, very good. What is the unit for thermodynamic temperature?
Kelvin.
Kelvin. Okay. So, what is the symbol for the temperature we are measuring?
K.
K. Okay.